Electrical jumpers are arranged on a de-energized system to provide either circuit protection or personal protection or both. Circuit protection is a form of grounding. Its primary objective is to prevent any damage or further damage from being imposed on the electrical system by minimizing fault current duration time, measured in electrical cycles. Circuit protection involves the bonding of de-energized conductors and/or equipment to an effective ground, so that in the event of an electrical fault or unplanned re-energization, the maximum amount of fault current may be generated and channeled back to the circuit's protected device through the system return or system ground reference in order to exceed the circuit protected device's programmed fault setting so that the circuit protected device operates, effectively de-energizing the line. It's a bit harsh to say that the circuit protection has no relevance for human life, so I'll soften that up a bit and just state that if you are fortunate, then some of the secondary benefits of circuit protection is that it may limit, not eliminate, but may limit electrical exposure hazards to the worker. Maybe. Where circuit protection revolves around grounding, personal protection revolves around bonding. Personal protection serves the worker. Personal protection ensures that the worker is maintaining an equipotential zone of protection by eliminating 2 points of electrical contact through the bonding of all the conductive elements that may be within reach or inadvertent contact of the worker. Some of the key points that help determining the differences between circuit protection and personal protection. First, electricity is fast. It's reported as being almost as fast as the speed of light, but not quite. And light purportedly travels at around 186,000 miles a second, give or take. And we have a 60 Hz electrical system, which means it produces a full 60 cycles of electricity every second. Second is mechanical physics. Circuit protective devices, whether they be fuses, circuit reclosures, circuit breakers, whatnot, are limited by the laws of mechanical physics. This means that peak efficiency circuit protected devices will still take about 4 to 6 electrical cycles from the time of detecting the fault current to the time of actually operating and effectively de-energizing the circuit. Now, since it takes circuit protection around 4 to 6 cycles to operate, then workers will still be exposed to those 4 to 6 full cycles of fault energy before that circuit protection has the ability to eliminate the electrical exposure. This is the key reason why fuses, circuit reclosures, and circuit breakers cannot be relied on to protect human life. Going back in time a bit. In the beginning, there was bracket grounding. It was considered the staple of personal protection. In actuality, it did little more than just provide a warm and fuzzy false sense of security for the worker. Bracket grounding is the practice of installing grounds on both sides of the work location. The intended purpose of doing so was that if the line became energized on the load side, backfeed being an example, then the load side of grounds would intercept and channel that fault current away from the worker. And if the line became energized on the source side, as in someone accidentally closing a switch, then the source side of grounds would intercept and channel that fault current away from the worker. In essence, it was commonly believed that the worker was safely boxed in, which is why bracket grounding is sometimes referred to as box grounding. This bracket grounding scenario was recreated under controlled conditions to find out just what would happen in such an instance. The controlled experiment induced a fault of 12,350 volts and 1,000 amps of current on the line. The results showed each set of grounds channeling 494 amps away from the worker. But the worker was still exposed to 12 amps of fault current. So, pop goes the meat fuse. This usually results in the defensive bracket grounding by someone inevitably posing the question,
why hasn't more workers died while using bracket grounding?
The answer is,
through the grace of God.
Or if you prefer, pure chance. We've established that electricity is fast, almost 186,000 miles a second. This being the case, then in those 4 to 6 cycles that it takes circuit protection to identify the fault and then to interrupt the fault, that electricity can theoretically still travel about 13,000 to 18,000 miles past that circuit protection before it is interrupted. And current will follow all paths, and why wouldn't it? Traveling at around 186,000 miles per second, it has plenty of time to peruse and find any and all available routes. When working on existing lines, the line worker is typically conducting pole top maintenance, which is the replacement of insulators, pins, braces, lightning arresters, and the like. If or when the line worker is handling the conductors, it's usually to remove them from the insulators or float them or lay them out on a hot arm. Whatever it takes to get them out of the way so that the real work can be done. In reality, the line worker's hands are not typically on the actual conductors very long, if at all. So if that conductor does become energized, the worker will have to be making contact with that conductor during that very small window of around 1/10 of a second of fault time in order to be shocked or electrocuted. Hence, pure chance. But it's not all doom and gloom. This isn't saying that bracket grounding doesn't provide any indirect benefits for workers. Installing multiple sets of grounds provides multiple pathways for the current to travel. This results in the fault current being divided up between the sets. This holds true in the example we covered, where each set respectively channeled 494 amps of the total 1000 amps of fault current. In addition, by having those grounds positioned away from the work area, ground worker exposure to the effects of step potential can be significantly reduced. Now that we've identified all sorts of ways and methods that can kill the worker, let's refocus on how to protect the worker. Personal protection is achieved when the electrical jumpers are arranged as to eliminate 2 points of electrical contact exposure for the worker. This requires that all potential points of electrical contact within actual or potential reach of that worker must be electrically bonded to ensure that there is only a single electrical exposure potential to the worker. At this point, everything is bonded. Nothing is grounded. Now, this is good, but it isn't great. Personal protection does not necessarily require a direct connection to an effective ground, although it is very highly recommended. If personal protective grounding is not bonded to an effective ground, then although the worker may not be exposed to 2 points of electrical contact, the fault may very well continue unabated, thereby trapping that worker at his work location. A practical example of this exact scenario are those cases where you can see operators stranded on their equipment that has made contact with an energized source. They are in an equipotential zone of protection, but they can't leave. Bonding the personal protection to an effective ground incorporates circuit protection. This is intended to de-energize the circuit in 4 to 6 cycles. Personal protection is designed to keep that worker safe during those 4 to 6 cycles. Here we've got a worker in a man basket inside of a substation. The buswork is bonded to the structural steel. The structural steel is bonded to an effective ground, which is the ground grid. Therefore, the buswork is considered grounded as well. This is your circuit protection. Is the worker protected? The man lift is not bonded to an effective ground, therefore it is not at the same potential as the buswork. As a result, if the worker contacts the buswork without dielectric protection, then he is the meat fuse. The structural steel is bonded to an effective ground, which is the substation ground grid. Bonding the man lift to the structural steel then grounds the man lift. Theoretically, the worker has now eliminated 2 points of electrical contact, therefore he is safe. But you must always consider your specific work environment. If there is ever a potential for voltage rise or induction, then the actual basket of the man lift should also be bonded to the buswork prior to the worker contacting it.